So, this is another routine question, and so the first thing to do is to define the function in the interval. So we'll split the interval 0 comma 1 based on the greatest integer value of 4x. So the first break would be at x equals to 1 by 4 when the greatest 4x becomes 1 from 0. Before that, function is identically 0 for x equals to 0 to 1 by 4, after which greatest 4x will become 1 and the remaining remains the same when x is in 1 by 4 to 1 by 2. Then it becomes 2 times x minus 1 by 4 squared when x is in it, then this is so now that we have the function defined, let's move on to the options. The function is discontinuous exactly at one point in 0 comma 1. So the points at which we'll have to check are the endpoints of the subintervals. So at 1 by 4 this is 0 and this is 0, so it's continuous. At 1 by 2 this is 0, this is 0, so it's continuous at half also. At 3 by 4 these two won't be equal because they are not 0, and this in fact would be twice this thing, and this is thrice this thing, so they will be different. So it is discontinuous at 3 by 4. So A option is correct. Then exactly one point at which the function is continuous but not differentiable. So again, with this option, the point of interest are the interval, the endpoints of these subintervals. So at 1 by 4 the function is continuously is constantly 0, so the left hand derivative at 1 by 4 would be 0. The right hand derivative would be from this function, but as the term of x, the term polynomial x minus 1 by 4 is quadratic, this term, so that is 1 by 4 is the repeated root of this polynomial, so the derivative at 1 by 4 would be 0. So yeah, then the right hand derivative and left hand derivative are equal, so the function is differentiable. The next is at x equals to half, then x equals to half, at x equals to half the right hand derivative would be from this and left hand derivative would be from this, and it won't be 0, so the limits would be different. The left hand derivative would be half of the right hand derivative because of this coefficient. So half is the point at which the function is continuous but not differentiable, so B is also correct. At 3 by 4 it's discontinuous anyways. Then the function is not differentiable at more than 3 points. This is incorrect because it's not differentiable at only 2 points, half and 3 by 4. And to check the minimum value, so the minimum value would be from this branch because otherwise the function is positive. So we'll have to find the minimum value of x minus 1 by 4 squared into x minus half. For which we'll differentiate this, so that gives us x minus 1 by 4 squared into this derivative of this is 1 plus 2 times x minus 1 by 4 to x minus half, so that gives us x minus 1 by 4. So again notice that 1 by 4 is a root as we earlier said, so this gives us x minus 1 by 4 plus 2x minus 1 equals to 0, which gives us 3x equals to 5 by 4, which gives us x equals to 5 by 12 is the point of, is the minima. At x equals to 5 by 12, the function value will be 5 by 12 minus 1 by 4 squared into 5 by 12 minus 1 by 2, which becomes 1 by 36 into minus 1 by 12 minus 1 by 432, which is not equals to minus 1 by 512. So D option is wrong. So answer is A and B. So this is a routine question, albeit a bit long, but should be done in the first attempt.